pretty strong activity in organic photovoltaics. This is a collaborative effort again with NREL. Tom Furtak, who's sitting up here in front, is one of the leaders of this effort. I just put up a few pictures here. There's a lot of things going on, but one system that we're looking at quite a bit, Sean Shaheen is sitting back there. Sean's one of the collaborators on the project. He's actually not from the Colorado School of Mines or from NREL anymore. You're from what? The University of... I think Denver. Denver, yep. And Sean's been a long collaborator on this project. Sean's actually the one who got us started working on it. So I want to give him his dues. The particular project that we're looking at here is actually building you know, when you make organic solar cells, things are a little bit different. It's harder to get the carriers out of them. You shine light on them, you make electron hole pairs, they're bound in excitons. The excitons like to stay bound. It's hard to get the carriers out. You need interfaces to do that. You need a lot of interfaces. The standard method that people use to get interfaces is to use a mixture of two things. Lots of times the mixture is a fullerene, a buckyball, and a polymer. In this case, we're looking at something that's more where the topology is more controlled, and that is a series of zinc oxide nanowires with polymer intercalated in them. And the part of the project that we've been working on is actually controlling the interfaces of those zinc oxide nanowires. And in particular, the idea is it can be hard to get the polymer to go down into the wires. It can be hard to get the polymer to have a good morphology. It can be hard to get good charge separation at the interface. And so we're looking at putting molecular monolayers on the surface and using those to tune the surface properties. So these would be organic molecules. And you run into some problems, and I just kind of want to point this image out right here. This is an atomic force microscopy image of this particular molecule. This is a thiol molecule with a long alkyl chain attached to it. And when you put it on the surface, the picture that I draw when I'm writing grants to the National Science Foundation is of a perfect pure monolayer on the surface. The reality is that when we put this on a single crystal surface, we find we get something like this. What we are doing is forming islands of the molecule, and in fact these islands have multiple heights, and so the islands are multi-level islands of the molecule. And this is something that's affecting our interpretation of the devices that result from this.